All right. Thank you. Thank you for the hype. So, hi, I'm Tomas Gonzalez. I'm with FossID. Before I begin, just a sincere order of magnitude gratitude to Guy Point and James for inviting us here to Jacksonville, rescuing me from the cold in Boston to come talk to you about SBOMs. I really appreciate it. This is my first public speaking session since joining FossID. To celebrate the occasion, I prepared this presentation just for you all. Nobody has seen this, so this will be the first time. So if you catch any hiccups or glitches in the presentation, let me know so I can make it better next time. So to get us started, just a little bit about me. I'm a Senior Director of Operations at FossID, been with the company around 9 months. I first ventured into AppSec in 2018, joining Synopsys Black Duck at the time, and that was the first time I ever heard of an SBOM. During onboarding, they defined it very literally, just like it's a list of what's in your software. And that worked great. People created SBOMs in request to an auditor that wanted a list of components, or somebody that they were supplying software to that said, I need to make sure that your software has components that don't get me in trouble. And that's as far as I understood it at the time, until in 2019, the NTIA released their famous document. I actually have to read the name because it's a mouthful. Framing Software Component Transparency, Establishing a Common Software Bill of Materials. That's a mouthful. But that was the first time I saw a model that actually defined formally, an SBOM, relationships between components, the creation and the sharing of the SBOMs, as well as the participants in the software supply chain. Almost immediately, but there were also some laggards, the tone of client conversations changed. The questions started moving from, I need to produce an SBOM to identify what's in my software, to I need to produce an SBOM because the people I supply software to are interested in understanding the risk that putting my software into their environment exposes them to. And it was a near immediate change. Since then, I've worked for two other ISVs offering software composition analysis tools. I've had the privilege of continuing to work directly with clients and system integrators, seeing how they implement the broader programs of which an SBOM is just a byproduct of a larger strategic goal. And so today I'm excited to be here, prepared this custom presentation for you all to share these booms and these experiences. So over the next 30 minutes, I'll be talking about some lessons learned, observations, best practices around the creation, maintenance, and use of software bill of materials. So no matter where you are in your journey for software bill of materials, I hope you like it and you find it informative. So let's get started. So for today, there's a flow that I planned. First, we'll do some level setting, as most sessions have already done. Talk a little bit about what software bills of materials are. We're then going to go into some of the hype around SBOMs. Why are people suddenly talking about this like it's a new thing when it's been around for so long? I'll share the 5 most common questions I get from clients around SBOMs. You might be surprised by some, you might not. We'll then talk about creating SBOMs, distributing SBOMs, and addressing 3 different types of risks in the software supply chain with SBOMs. After that, we'll close it out. The way this is planned out, we should have about 10-15 minutes for Q&A. Let's see how that goes. Nothing ever goes as planned. So, first off, let's set the stage. What is a software bill of material? Who produces a software bill of material or knows that their company produces a software bill of materials for their applications? I'm so glad I'm doing the level setting. Okay. So the first thing to know before we answer that question is just know software contains components. There's a lot of third-party components in software. These can be proprietary, these can be commercial, these can be open source. Especially when open source components are being used, an SBOM is almost always involved. You would be very hard-pressed to find an application that does not use open source components. They do exist, but they're kind of rare. And so when you're talking about defining an SBOM, the closest parallel that you can think of is a list of ingredients in your food boxes. You buy a box of pancakes, and it has a list of delicious ingredients that come together and make the final product. So if you have that analogy in mind, here's the literal definition of an SBOM as defined by the NTIA. It's a formal, machine-readable inventory of software components and dependencies, information about those components, and how they're all related. Now, it's not as tasty as a box of pancakes, but the software bill of materials looks kind of something like this: a whole bunch of machine-readable gibberish that computers can make sense of, and risk management systems can ingest, and all sorts of inferences and decisions can be taken based on the information that it contains. So beyond its functionality as an inventory, if you think about your perception as a software vendor, your clients see an SBOM as you knowing, here's what I'm giving you. This is everything that's in the software you're going to be deploying into the environment. It is you stating confidently, this is the risk or not risk that you will be adding into your environment by acquiring my software. And at a very high level, that's what an SBOM is. So why, if SBOMs have been around for so long, why are we starting or continuing to hear about them now? So let's think about what led to this. Has anybody been to a restaurant and you see a sign that you weren't expecting to see in the restaurant, such as, don't let your kids get on the table? I don't know if you've seen this, but almost always, if you ask the staff at the restaurant, yo, what's up with the sign? They say, well, somebody actually let their kids on the table, and that wasn't nice. It was nasty. And so a similar thing happened that led to SBOMs becoming a big deal. You probably heard of Apache Struts. You probably heard of Log4j. Probably heard of SolarWinds. Probably heard of the MoveIt file transfer vulnerability. This just happened last year, where many systems were impacted. So the reality that these events reinvigorated the case for SBOMs, and it stemmed from these high-profile incidents that all of a sudden, when companies were asked to give evidence of, hey, what's in your software and is it going to put me at risk, many companies were not able to answer the very simple question of what components are in my software. And so what happened? This inspired a regulatory response. You've probably heard of Executive Order 14028. Probably heard of the EU Cyber Resilience Act. These are the two quintessential pieces of regulation that many companies refer to when they're saying, why do I need to produce an SBOM? Oh, I need to be able to transact with the federal government and they want an SBOM. I need to be able to transact with the FDA and sell them my medical devices. I need an SBOM. So these two pieces of regulation reinvigorated that conversation. That had already been happening. People were already producing SBOMs before, but this is a big reason for why it's in the news again. The good news that this is not like COVID, where suddenly crisis hit, nobody knew how to react, everybody's scrambling trying to figure out how to do it. SBOMs have been around for long enough to where producing an SBOM is down to an art by now. And so we can really learn from these companies that have been producing SBOMs up to this point, take their best practices, not stumble through their lessons learned, and implement it into our companies, which apparently, if none of you are producing SBOMs, this is a big relief for all of you. So, one more thing that's kind of exciting is because of the new hype, there's a lot of innovation in the space. We're going to talk about things like VEX, that was mentioned earlier. Reachability was discussed earlier. Runtime evidence to determine if vulnerabilities are actually exploitable was discussed earlier. There's a lot of innovation in the space as a result of this new focus on figuring out, of all the noise of security vulnerabilities, what's actually relevant. So, for the first part of my presentation, this is from the NTIA's document that I read the mouthful of earlier. There's three categories for tools related to producing SBOMs. For the first part of my presentation, I'm going to talk about the producing category. These are how you build, how you analyze, and how you edit an SBOM. So, Before I do, let me just tell you what the 5 questions that I've been most asked by clients are in relation to SBOMs. So, number 1 is, what software should I produce SBOMs for? Does anybody have a guess?
All of it.
All of it, that would be correct. But if you didn't produce it for any of it, where would you start?
You make yourself.
That's good. That's correct. Stuff you make yourself and stuff you make available to clients specifically, right? They are the ones that will most likely ask you for an SBOM. They're the ones that will be holding you to account to produce an SBOM as a requirement for the software that they buy from you. So if you have to prioritize, you're right that you should do it for everything. But if you have to start somewhere, start with the software that you make available to clients. This is your SaaS offerings, anything they deploy on-prem, any embedded device, anything that is used as a subcomponent in a vehicle. These are the key things where the need for an SBOM is most critical. Now, that said, we're going to discuss this a little bit later. Building SBOMs for your software is part of a much larger risk management strategy, so it is good to produce SBOMs for everything. Internal projects, open source projects that your team contributes to, and so on. So, second question I get asked, what should be in an SBOM? Spoiler alert, my graphic wasn't supposed to load, but the short answer is everything. So this is, again, what the NTIA says about this. An SBOM must enumerate all third-party software dependencies, open source and proprietary, incorporated into the supplier product, as well as any dependency that's required, that's installed at runtime. So that last part is pretty key, because if you have a software that you make available to your clients and they deploy it on premise, and your SBOM only has what you're providing them, but then the installer for your software downloads 50 other dependencies, and you're not reporting those in your SBOM, you're potentially not telling your client all the risks that are associated with your software that they're installing into your environment. So this is a key piece that many people miss. They say, oh, I just need to worry about what I'm shipping. It's like, no, yes, actually, but you should also include in your SBOM those components that are installed by your software in the cases where you're not actually delivering software as a service. So, third question that I could ask. Oh, before I do, I got ahead of myself. So, the most popular case for SBOM really was reinvigorated around open source components. And just to double click a little bit on this, to level set, there's 4 terms that we at FossID use to talk about the different types of open source in a code base. This is managed, unmanaged, declared, and undeclared. And so what does this mean? A managed piece of open source is open source that is managed by a third party, by an extra utility, in most cases a package manager. So if your applications are written in Java and you use Maven or Gradle, if your applications are written in Node or JavaScript and you use NPM, if you use Paper Poetry for Python, etc., etc. This is what we're referring to with managed. Unmanaged means that you don't use a package manager. There are many programming languages out there that do not use package managers. The one we hear about the most is C and C++. The difference being, like, they do have to copy the binary into the file tree at some point, but the user, unless they have a third-party software catalog, is usually responsible for storing those in a directory where they can easily be found, taking inventory, tracking the versions, tracking the vulnerabilities. It's a very manual effort sometimes. We'll talk about that. And then we have declared and undeclared. Declared open source means open source that somewhere in the code there is a mention that that package is there and that it's being used. So this applies to both managed and unmanaged open source. So if you have a package manager manifest that says, I need Boost, and then somewhere in a file in your application you say, from Boost import whatever function, that's a declaration. You're saying, from this package, I need this functionality. And then you have undeclared open source. This mostly happens when developers get lazy. They're trying to figure out how to implement a particular algorithm, or they're trying to figure out, how they can implement a particular function. They go to Stack Overflow, they go to GitHub, they copy paste some code, they download some code, they rename the variables to make it look like their own work. This is a sneaky type of open source that is usually hidden. in the code. So that said, some examples. You can combine these. Manage declared components, that's usually everything that comes through a package manager. Unmanaged declared components, and that's not really a good graphic for this, but these are include and import statements. This is a header example from C and C++. And then undeclared open source can refer to many things. It can be a snippet of code, it can be a single file or a script that was downloaded from GitHub, it can be just a license that is buried somewhere in the code base. Now, this is all open source. What about commercial components? The answer is yes. You need to include those in your SBOM. The NTIA said it. There's really not much more debate about that one. Now, one thing worth knowing before I go to the next question is that SBOMs are really not one size fits all. There seem to be some clients that, in our conversations with them, I tell them, you can't just produce one master SBOM, and that'll satisfy everybody's needs. There's actually 6 different types of SBOMs. The client are designed by the NTIA. When I was researching this presentation, I was surprised to find out about this because I had no idea it went this granular. But when I thought about it, it makes sense because of what we discussed earlier. What's in your source code? What's actually deployed into an environment? What's actually exposed and available and running when the application is deployed at runtime? And so the reason that I mentioned SBOMs are not one size fits all, imagine a scenario where you offer the same application in both a SaaS deployment model and an on-premise deployment model. Deploying the application that a client installs on-premise will have a lot of the same information as your SaaS application, right? It's fundamentally the same application. But you're gonna have a whole lot of other instrumentation in your SaaS offering: observability, performance monitoring, benchmarking, web application firewalls, all the infrastructure components that you're using that a client might not. If you produce an SBOM for a client deploying your software on-premise and you include all the components from your SaaS bill of materials, you're giving them noise. You're giving them more information that they're gonna be able to action on. And so it's really important to consider how is the application that you're distributing to the client going to actually be used, and what scenario are they going to be deploying it, so that you give them an SBOM they're actually going to be able to action on. Up next, question number 4. Curious if anybody knows the answer to this one. What information should I include in my SBOM? I heard something, but I didn't quite catch it. Everything. Yes and no. At the very least, there's 7 things that the NTIA wants you to include in your SBOM. It's just what vendor, what's your name, what's your components' names, what's the version of the components, what uniquely identifies those components, are they related to any other components such as direct and transitive dependencies, what tool did you use to produce the SBOM, when was the SBOM generated. This is the minimum of what you should put into an SBOM. And depending on whether you're dealing with specific industries, then you might have to put additional elements into the SBOM. For example, the FDA wants vulnerabilities. They want the support status of the components that are in the SBOM. They want the end of support date for the components in the SBOM. End of support and support status in particular mostly apply to components that are of a commercial nature, not necessarily open source components. So when you're thinking about what information you need to include in your SBOM, consider this. What is the end outcome of producing an SBOM? What regulation is it going to help you comply with? What information do you need to provide so that they don't reject your SBOM? Something that I don't like is when a client comes out to me and tells me, Tomas, I need to talk to you. It's like, what's up? It's like, I produced an SBOM with a different tool, and it was rejected by a regulatory authority. So now my release is delayed. I can't transact. I can't meet my deadlines. It's just, this is also avoidable. It's very easy to avoid. The information's out there. But so, I digress, work backwards from the outcome. What do you need to comply with? Then put that in your SBOM. So, one other question I get, who's responsible for creating SBOMs?
Everyone.
Everyone, it's a good answer. What team specifically would you say is responsible for producing SBOMs? developers are good. That's ideally, that's what you want. So that's usually the first question that comes up. Do we need to make the SBOM, or should I hire a third-party auditing firm to do it? The answer is, ideally you want your software development team to do it. Why? It's good practice for engineers to know what's in their code base. It's good practice for them to know what they're shipping. This is just good engineering etiquette. And then you sometimes hear, but they're busy. I can't produce it. What should we do? Push back. You should understand your code. And there are automated tools out there that can help. You just gotta take the time to put it all into place. Work a little bit of time into your sprints and see if you can convince your engineering teams to do it. And then I've also gotten this one, is I have a 20-year-old legacy application, none of the developers are still there. Nobody knows how it works. Like, how am I gonna produce an SBOM for that one? Again, tools can help. There's many tools out there that can produce software bills of material by analyzing through fingerprinting the components of your code base, matching it to knowledge bases that they have created, and then telling you, here's what we think it is. There is some due diligence involved, but then if you get, oh, but I don't have the time, then there's external auditors, like the same ones that do software audits in the context of merger and acquisition transactions that can help you build that baseline. Once you have the baseline, you're off to the races. You go from there. It's not like the 16-year-old application is getting updated anyway. Maybe it is. So, the last question I get, how often should I create an SBOM? Anybody want to take a guess at this one? So, yes, yes, and yes. So this is actually the easiest one to answer. Is if you're operating on releases, like version 1 of your software, version 1.1, version 1.2, an SBOM for every release. Like this way you have a history. A client is running version 1.0 of your software, somebody else is running 1.1, somebody else is running 1.2. You want to have these versioned software bills of material in case any new vulnerabilities in particular are disclosed for those components. You can very easily know who you have to contact proactively to tell to upgrade to a new version of your software. If you're operating continuous deployment because you have a SaaS application, just update your SBOM every time code is merged into main. And that way you can always produce an SBOM from the latest state of the code you're making available through your SaaS application. So those are the 5 questions I get most from clients. I'm sure there are more. This is why I'm leaving time for Q&A afterwards. So moving into the next topic, let's talk about, now that you know who creates it, what has to be in it, what do you have to include, what information has to be there, and how often you have to create it. How do you actually go to create an SBOM? Ideally, as we mentioned, engineering should integrate SBOM creation into software delivery process. Once you have SBOM creation as part of your standard build and release process, creating and communicating it is an automatic byproduct of every release of your software that you make. So for organizations that aren't yet producing SBOMs, or maybe are in the process of establishing that, it's likely that your engineering teams might not be providing you that list of components. So how would you go about getting it? Let's talk about that. So some options you have for formulating your SBOM. Number 1, ask your product and engineering teams. Usually, any first step to understanding what's in your software, somebody knows. A product manager, a compliance manager, a release engineer. Somebody has to have a list of the components in your software, and usually the people that are responsible and accountable for any action taken by engineering, a product manager, VP of engineering, compliance manager, will have that list. Now, the one who can actually bridge the requirement between the engineering and the requirement for the engineering team and what you need to produce for the SBOM, they're ultimately seen as a hero, right? Because you have the component list. Your second option, software composition analysis tools. These are not new. This is what I was mentioning earlier. These are automated tools that can scan your code base and tell you, oh, this is what's in it. So software composition analysis have pros and cons.
If the engineering or product teams are just unavailable to help, one of the major pros of software composition analysis tools is that you often don't need to get a developer to integrate a test into the pipeline in order to perform a scan. Just zip up your code, submit it to the tool, you get results. This is something that can be done to gain visibility over the components in your software without really running into that objection of, I don't have the time to put it into the pipeline. Many software composition analysis tools can produce SBOMs in the standard formats that are required by organizations. Now, FossID offers software composition analysis tools, so I'm going to shoot myself in the foot here a little bit, but I'm here to inform, not to sell. Purely relying on software composition analysis without involving engineering and the product teams may not help you properly identify every component. There's a disadvantage that software composition analysis offers, that it may yield false positives. You may identify software components that aren't actually included in the shipment of the application. They're only used in the development of the software. Perhaps the biggest disadvantage of relying exclusively on software composition analysis is that you're not automating SBOM creation as part of your engineering delivery workflows, which we stated already is a good engineering practice. So through a combination of the two, SCA tools together with engineering's know-how of the components and the parts of the software, you can make SBOM creation a standard part of your build and release process. If you have a bandwidth constraint and the team is not available to provide that expertise, you always have third-party auditors that you can employ to help you, again, build that baseline. Once the auditors help you build a baseline, you're off to the races. You can continue producing the SBOM from there. So mix and match. Mix and match the different approaches. The important thing is you need to produce an SBOM for your software. So, now, when we talk about what the data of the inside an SBOM looks like, as you saw before, it's a very uninteresting thing. It's just a big index dictionary of key value pairs. There's three formats you've probably heard of: SPDX, Software ID, or Software Identification Tags, and CycloneDX. Until I was doing research for this presentation, I will admit I had only heard of SPDX and CycloneDX, so this was kind of surprising to me to learn about SWID. But the point I'm going to make here is that no matter what format you decide to go with, and there are certain regulatory bodies have certain preferences. I know SPDX and CycloneDX are the most widely accepted ones. I haven't really looked deep into SWID. But no matter which one you decide to use, there are tools that will help you validate that the SBOM that you're producing in those file formats is actually in the correct file format. So what they do is they just see, are all the required fields there? Do you have information in the required fields? You're good to go. So these validators can help you make sure that the SBOM you're producing is going to, effectively be machine readable by the people that receive it. Remember, nobody gets this and starts to look at it one by one, line by line manually. This is all fed into extract, transformation, load processes that can then be used for a bunch of downstream calculations and risk assessments. You need the people that receive your SBOM to be able to parse it with computers, not with eyes. And so these tools make sure you can do that. Since I found out that you're all going to get access to these slides, I included a little diagram in here for you all, just with some of the minimum elements highlighted on the left. I will admit this was updated last March, so sorry if it's out of date. But it gives you an idea of some of the differences in the different SBOM standards, what fields are mandatory, what are optional, and what's kind of built in. So just to drive the point that there are some inconsistencies in what the different SBOM standards require, but follow the guidance from the people that you actually have to provide an SBOM to. Now, let's talk about distributing SBOMs. You made the SBOM, yay! Now what? So once you produce the SBOM, you run it through a validator, and everything looks good. Again, we discussed there's no one-size-fits-all solution for producing an SBOM. So what you need to do is make sure that the right people have the right data at the right time in order to make the decisions that they need. So How would they do that? So the NTIA document talks about the two first stages, advertisement and discovery. Those kind of go together. And then there's access. And advertisement and discovery just means letting people know, letting your clients know, hey, there's an SBOM available, here's where you can get it. Pretty straightforward. This could be a URL, it could be a manifest, it could be a published subscribe view. It can just be, how are you gonna get the SBOM to the people that need it? And then the more fun one is access. Access is a little bit more actionable, but it's how you're gonna transfer the SBOM using the method that the client selected during discovery. So, for example, you can provide the SBOM via an email or some other form of informal communication. This is optimal when there's no automated process for delivering the SBOM. So it's a less preferred method because it's not really easy to automate, and part of the whole goal of producing an SBOM is to have it automated as part of your software delivery process. So it's an option, it's not ideal, it works, some people might like it, not necessarily ideal. Number two is storing the SBOM on software or device that you ship. You know, there might be, if you browse the file tree of the Linux device that you're shipping, or the Docker container that you're shipping, or the installer of the software that you're shipping, somewhere in there is the SBOM for the software. This is also pretty effective if you have a system that exposes an API that somebody can hit your system and say, give me SBOM. So this is actually a more preferred example because you can actually automate it as part of your software delivery process. And the third one is just a repository. Not as interesting, but just a repository or a bucket where the client can access it either publicly or privately. There are some people that publish public SBOMs for their software. This is very useful if your system does not have an API or a way to expose or publish an SBOM. So for more information on this, I put a link in here to the NTIA's guidance for sharing and exchanging SBOMs. It is more than I think you want to hear me talk about during this session. But those are the key things to look over. Up next, just something to consider about confidentiality. This is a question I get a lot. It's like, I don't want to tell people what's in my software. What if they find out I have a component with vulnerabilities? That's kind of the point. I've actually gotten that question before. So the confidentiality of the SBOM can really vary depending on whether it is generated or provided by a vendor, contractor, or an employee from an open source development community. That's actually straight from the NTIA's document. Next is you want to declare the licensing status of the SBOM and the SBOM. If your client is under an NDA and they want to share it with a supplier, a vendor, a system integrator, just make sure there's an NDA there as well. But clients should be able to use your SBOM as they need it and share it with third parties as long as they're subject to the same NDA. Why? Because they might have an MSSP that's helping them with risk management, and your SBOM is a vital part of that. This is needed when a client buys your software and they need to operationalize their risk management from the information provided in your SBOM. So again, this is yet another NTIA document, not the same one, but it's a playbook on SBOM acquisition, management, and use. I put a link to that one there as well, so you have it. Oh wow, we're almost done. So let's back up. You might be wondering right now, Tomas, you're giving me a lot of information, but why does this matter? Like, why do I care about this? And this is where the risk conversation comes into the picture, because that's why we're all here, right? We're trying to reduce risks. So let's talk a little bit about what risks the SBOM can help prevent and address. Most popular, most heard of, are security risks. I brought up 4 big high-profile security vulnerabilities earlier. So the big things to know is that these security risks can apply to open source and commercial components. This is why commercial components have to be in the SBOM. Next, there's open vulnerabilities in open source components. Now, what I'm about to show you is not an official vulnerability scoring system. You've heard of I don't know if you've heard of the CVSS, the Common Vulnerability Scoring System. This is the TVSS, the Tomas Vulnerability Scoring System. but it relates to how we were talking about how does open source make your way into the code base earlier. In my mind, one of the highest risks are components that are declared but they're not managed by a package manager. Why? Because if you don't know they're there and there's a vulnerability reported for it, it can stay hidden in plain sight and you might be subject to a vulnerability, and if you don't have a good inventory of the component because it's not managed through a package manager, that can leave you open. Second, I say the declared managed components. This is everything that is introduced through a package manager. And why do I rank this lower? Is because most package managers nowadays will tell you, hey, there's a vulnerability for this component. You just don't get that if you're running dependencies in an unmanaged way. And many package managers will actually automatically update your dependencies for you if any of them have vulnerabilities. We're going to talk about why that may or may not be a good idea in just a little bit. And then the lowest risk comes from undeclared open source. If you're copy pasting code from GitHub, you have to be really, really unlucky to copy paste the exact lines of code that expose you to a vulnerability. I'm not saying it can't happen, it's just wildly unlikely. And so, that said, I preface this, your mileage may vary, this is kind of general guidance and just purely informative. The second, and this is the one I first heard about SBOMs for, these are license compliance risks. Of course, I was working for tools that did software composition analysis for merger and acquisition transactions. And the open source licensing landscape is complex. There are over 2,000 open source licenses. I think the OSI has approved about 600 of them, so there's about 600 well-known licenses, which leaves about 1,400 licenses that are effectively the Wild West of compliance. The reason this is tricky is because anybody can create a license. There's actually a beerware license, where the maintainer says you can use this component commercially if you buy me a beer. And so I know of legal teams that document, like, hey, we bought a 6-pack, we shipped it to the maintainer, we're in the clear. You need to be able to track these things. And so licenses range from copyleft. You've probably heard of the GPL license, the lower GPL, the Affero GPL, the Mozilla public licenses. These are licenses that have commercial restrictions. And if you incorporate them into your code, then you run the risk of having to open source all the code that you integrated into. I don't know if you remember a few years back, this happened to Cisco, which they acquired Linksys. Linksys used the GPL license component in their router firmware. Cisco was sued. They had to open source the firmware for those Linksys routers. That's why you could get into the firmware and get $300 router functionality out of a $50 router. So the impact of this is real. Now, if you ask Cisco what they think about this, they love it because it made that their best-selling router ever. So there's pros and cons to this. Then you have permissive licenses. These are the ones people like to use. The MIT license, the BSD, the Apache license. These are the ones that say, you can use this open source, you have no support, good luck, have fun. And there's many popular open source packages that are permissively licensed. And you have source available licenses. You've probably heard of these if you've been following MongoDB, Redis. I think Terraform recently changed their license to a source available license. These are licenses that have restrictions on the commercial use of the component, but you can use it for prototyping and experimenting on a personal basis. And then you have straight up commercial proprietary licenses. The best way to get this under control, if you don't already, I recommend establishing an open source program office. An OSPO is a great way to say not only what licenses can and cannot you use, but also how your team can contribute to open source projects. Because if your developers want to use open source, chances are high they also want to contribute back. So that's the second type of risk. The third one is dependency risk. This one's a little bit iffier, but this one just means that, let's say you find an open source project that is perfect. It meets your use case, it has all the features you want, it's fantastic, I love it. You want to do a little bit of due diligence on that open source component, besides the vulnerabilities in the license. How large is the maintainer community? Is it maintained by a kid in his garage? Or does it actually have a healthy community of maintainers? How active is the community? How long has the oldest pull request been open? If somebody's trying to fix a vulnerability and the pull request has been open 2 years, that tells you something about the health of that community. Have they changed their license recently? I brought up Redis, MongoDB, Terraform. These are great examples. Do they have corporate backers? So one of the most popular JavaScript frameworks, React, is a project from Meta. And so it's a very popular project used in most JavaScript web applications. Do they have contribution guidelines? Again, teams that use open source typically want to give back. It helps build cloud. It helps get them recognized within the community. And what company do the maintainers work for? Because there might be a conflict of interest, especially if you have export disagreements with the company that perhaps contributes to a project that you want to use. So this is just part of doing due diligence on open source components to make sure that they're not introducing these types of risks. A lot of this can be informed by an SBOM, because the SBOM has the list. So, quick recap. Increased supply chain transparency with SBOMs can reduce these risks. I mean, based on what we discussed, I think that if there's anybody that doesn't believe that, let's talk about it. I think that's something that I'm always willing to learn more on. So it improves the ability to identify vulnerable components. It reduces unplanned and unproductive work due to supply chain disruptions. If a component that your application depends on is no longer maintained or completely gets deleted. It allows vendors that support that level of transparency to build trust with the people that they supply software to, which is an opportunity for differentiation in the market. It reduces duplication of efforts because it standardizes, data sharing formats across multiple sectors. And it facilitates the identification of suspicious or counterfeit packages. Because most SBOMs require the hash of the component. That's a really good way to figure out if you've had a dependency confusion attack or if somebody tried to spoof one of your dependencies. So, we've all been talking about AI, so I added this section over the past few hours because I want to sprinkle some AI love into this one. We couldn't be complete without a segment on AI. So, how do you de-risk generative AI coding assistants? So specifically because most of them are trained on open source code. So the quintessential example, this was GitHub's disadvantage for being first to market, but they've since fixed this. But they had a setting in Copilot where you actually had to tell it to block generating suggestions that matched public code. And this happened because people were realizing, maintainers, with GPL licenses, the very copyleft ones, saying, Copilot is spitting out my copyleft code. Not entirely, but the code that Copilot is spitting out is copyleft. Not cool. And so Microsoft had to go into a little bit of damage control in that there was actually a lawsuit opened up against Microsoft GitHub OpenAI for violating copyright law, for reproducing open source code using AI. Second is, before I do, just some examples. Amazon's Code Whisperer, to show how important this is. They actually say whenever any generated code is under a license. And they will add that license as well as the snippet of code into a file so you can track it. Then provide proper attribution. Codium, their value proposition is that we don't train on GPL code. We only train on MIT, Apache, and other permissive licenses. Much less risk. IBM, Watson's Code Assistant, they say, we'll train it on your code. We don't even train it on open source code, we'll train it on your code. And so there's different ways that different generative AI vendors are addressing this risk of license compliance. So, other things you can think about, security risk, still a thing. So Sneak put a blog post recently reinforcing that if you have insecure code and you train your AI on insecure code and you use AI to augment your insecure code, it's going to spit out more insecure code. And in support of that value proposition, that's why you saw they partnered with Google. So anybody using Gemini Code Assist gets their SaaS offering, sneaks under the covers, to do quality checking and security checking on AI-generated code to make sure it's not going to introduce any vulnerabilities. Dependency risk, if you think about it, if you ask generative AI, write me an application that uses this open source component or uses a open source library to perform this function, it will indiscriminately recommend a package. You have to ask yourself the same questions we covered earlier. What is this package Gen AI is recommending? Is it good? Is it sustainable? Can I use it over the long term? So just do your due diligence. Whenever a Gen AI coding assistant says, I'm gonna use this open source package, double check that. And then finally, license compliance. We talked about this already, but there are tools out there that can do scanning down to the snippet to figure out if any of the code that your Gen AI coding assistant spat out is licensed under the open source licenses. Okay, wow, so close. So, how do SBOMs help mitigate all these risks? There's a second category of tools called consume. These are very interesting. It's effectively where you ingest the SBOMs from your suppliers in order to be able to analyze and action on them. Because really the value of an SBOM is the action that it inspires, right? So how do you break those barriers down? So just ask, whenever you're interpreting an SBOM, you ingest it. Does that software contain any risky licenses? The SBOM will tell you right away. This is one of the first questions that is usually the strongest go, no-go decision. You get an SBOM, it has a license we don't support, sorry, I can't do business with you. Second is dependency help. Many organizations, especially those with open source program offices, will say, I don't allow your software if it has components that are end of support, and for good reason. So the SBOM again provides transparency into just giving them the confidence that your dependencies aren't gonna result in downtime later. And third, security. With the SBOM having the unique identifiers for the components, many tools can look up in the vulnerability databases and figure out if there are any vulnerabilities disclosed for those components. Now, I want to double click on that last point because addressing security issues can be easy, but it can also be very painful. If it's a relatively easy fix that can be applied by just bumping up your dependency, because it's a minor version upgrade, fantastic, that's easy. But what if it's a vulnerability in a transitive dependency and the direct dependency has not yet updated to reflect the new version of the transitive dependency? You can't bump up the transitive dependency or you'll break your direct dependency. Same thing, what if your direct dependency has a fix in a new version of the major, or a new major version that would result in breakage to your application if you bump it up? So one thing that the SBOM can do in the cases that security remediation is difficult, it can inform mitigation. It can inform WAF rules. It can inform downtime. It can inform failover. That information will help you reduce the time between when the vulnerability is disclosed, when it starts being exploited, when a remediation action is taken. So again, like most application security scans, the SBOM is only as good as the action that it inspires. And this is where tools that ingest SBOMs can help. They can help greatly, but context is important. So consider the scenario when new vulnerabilities disclosed once again. Your tool queries the NPD, suddenly says, there's 100 vulnerabilities in the component, what do I do? A CVE for a component is not an indication of real risk. And I broke it. That's it. Oh, there it is. So this is where things like VEX are really interesting. So this is just some areas where SBOM innovation is really getting kind of cool. It's a companion artifact to the SBOM where suppliers can say, I analyzed this vulnerability, it doesn't apply to my code. Transparency, you don't have to worry about it. There's no need to panic. This is I believe I heard it mentioned in one or two sessions before. This is really a really interesting area to watch. The second area that's really interesting is how people are building dynamic SBOMs. They have a static SBOM, they have some instrumentation in the runtime environment where the cluster is running. They figure out, okay, what's actually loaded at runtime. They compare that to a threat model. They figure out what their attack vectors are. And then they say, well, out of the 100 vulnerabilities, we only care about 10. This is a really, really cool area of SBOMs as well. So, in closing, again, thank you all I hope you enjoyed the first time I did this session. We talked about SBOMs, past and current events driving interest, the information in SBOMs, their structure, their formats, some areas where the market is evolving. We learned that putting together an SBOM doesn't have to be hard. And we learned a little bit about the risk management workflows that can be powered by consuming your supplier SBOMs as well as producing your own. So thank you again for the opportunity to be here. I hope this was informative, and I pass you over to the wonderful last session that's coming next. Thank you all.